Stone Air Penetrator 120i Pro advertises itself as one of the best airflow fans for your computer case. Well, I hope you'll join me on this video as we discover why and see if it lives up to that reputation. At this time, I'd also like to thank Silverstone for sending me this fan for a review sample. No money exchanged hands, they just like the way I review products. And, well, that's that. Let's get into it. First, a little bit of spec. It is pretty much a standard 120mm class fan, dual ball bearing, 2000 RPM. There's a CFM and static pressure. All right, so this is the 120i Pro, and this is the 120i ARGB. And you can see that there's some fundamental differences in the blade design. And the Pro has smooth blades and two different blade designs. Let's zoom in on that real quick. So you can see that there's a little bit of curvature on this one. So it actually curves in and then tilts back out. And you got these fat blades. So it has 1, 2, 3 fat blades, 3 of these super skinny weird ones, and then 3 more of these other ones. So it's creating a very unique, I guess, overall fan design with an odd number of each type of blade. So 3 total different kind of fan blades on it. Here's the back of it. And of course it has the air penetrator fins. And it's just like the ARGB version of it. No differences there. The ARGB is just regular old fin designs. I just want to demonstrate that. So overall, you know, the special thing about the air penetrator is this back fins. It just strains out the airflow, and well, we're going to see in the testing how well it does. It'd be interesting to have a comparison of this fan without these fins in the back. Unfortunately, to do that, I'd have to take my Dremel and cut them out, but I'd probably not do it right because there aren't any real struts. These are the struts, so it wouldn't be a good comparison because they may reduce the structural integrity of how the motor is placed in it. So I'm not going to be doing that. So the first test is the case simulation. This is in a box that can hold up to 200mm fan, and I have it set at various distances away from it. That is the rough distance from the front of the case to your CPU socket where the CPU fan would sit. So it is looking for the optimal airflow inside of your computer case. You want maximum airspeed before it hits that air cooler. This test is specifically designed for air-cooled type systems. If you're looking at a mini ITX compact case, like a DAN case or something like that, this section is not for you. If you're looking at AIOs, this isn't really applicable. But it is applicable if you plan on having fans at the bottom of your computer case blowing up towards your GPU. That is the 6-inch mark. It is also applicable towards mini ITX cases that do have a front-to-back airflow with the tower cooler in it. So if you're looking at that, you want to take a look at the 6-inch mark for your main airflow speeds. Next, we're at the 9-inch mark. This is like 220mm class fans. I think of this size as a media center PC. So focus in on that. If that's the case, computer size you plan on building into. The 11-inch mark are your standard mid towers, 320mm class fans. And at the last data point is 14.5 inches, 340mm class fans. And this would be your truly large towers, something like the Frock Design Torrent. So we need a baseline to compare fans against, and I have a control fan that is based 3 parts A12X5 to 1 part A14. And it is this kind of light greenish line with a triangle on it. The Air Penetrator 120i Pro is the blue line with the box. And I have a couple other Air Penetrator variations that Silverstone was nice enough to send me. And it's pretty clear that at shorter throw distances, the control fan is a bit better, but as cases get larger, the Air Penetrator, particularly the 120i, do better. So this is, again, at noise normalized, my 10.5 decibel reading. And as we bump up to 100% PWM fan signal, all the air penetrators do significantly better than my control fan. However, they all zero in on roughly the same point, despite vastly different RPMs. So there is just a limit to how much the air can focus. Again, this test is not CFM, it is an airspeed at roughly the center of the box. Now we're going to compare this against other fans at my 10.5 decibel reading. And how does it compare? The Air Penetrator 120i Pro is this yellow line. It starts off towards the bottom of the pack. It isn't delivering the most air at a particular RPM, but that is the nature of its kind of the design, I want to say. So if we remember from the earlier section, when we look at the back, it has all those gills or fins, whatever you want to call them, on the back that helps straighten out the airflow. Well, that has a side effect of increasing the noise level. So there is a trade-off to having the best focused airflow, is that it can't spin as fast, so it can't kind of shove air through the computer case. But the air that you will be getting potentially is higher quality. Unfortunately, my test, I don't really have a smoke generator. I'm not in an environment where I can operate a smoke generator to truly visualize how airflow patterns are going through the box. I can only take airspeed measurements. So it could potentially be a higher quality, more streamlined air, more laminar airflow than the other ones, as opposed to turbulent air. But it is just noisier, and that is kind of the end result that matters most, I'm going to say. The winner here is the TLS-12, the W variant. Taking a look at the same thing, this time in bar graph form, we're going to keep it moving. Now we're at my 17.5 noise normalized reading, and the Air Penetrator 120i Pro is still shifted towards the bottom of the pack at the 6, the 9, and the 11, but when we're hitting the 14.5, it is still towards the bottom, but it is closer to the pack, but it is still towards the bottom end of it. So clearly it's still on the noisy side for the amount of airflow it can generate, especially compared to some of these other fans. Same thing, bar graph form. The winner here is the TLB12 Extreme. And bumping it up to 100% PWM fan salient. This just lets the fans go balls to the walls as fast as they can go. Noise be damned, basically. Case fans should, generally speaking, not be operated at 100% because it would be very noisy. But the Air Penetrator 120i Pro certainly does an admirable job, and it's sitting right in the upper middle of the pack of this good fans. So if we're particularly looking at the 14.5 inch mark, it is one of the better fans. It isn't sitting in the best position, but it is in, third, fourth place. It's tied with a couple other ones. So it's definitely doing a fantastic job here. Locking into specific RPMs, 800 RPM, the Air Penetrator is noisier than the other fans, but it's delivering comparable air speed. Moving things up to 1,500 RPM, it is doing, well, it's ranked in third place, but it is keeping up really quite well with the other top-end fans on this graph. But once again, if we take a look at the noise levels, it is quite a bit noisier than the other fans around it. Again, nature of its design. And at 2,000 RPM, well, it's competing right in line with the TLB12 Extreme, which is spinning at the exact same speed, 2,000 RPM. But once again, it is almost twice as loud for the same general ranking here. Now we're looking at airspeed versus that decibel reading. So it's noise versus air speed at the 9-inch mark. And the Air Penetrator 120i Pro is sitting kind of in between the best fans and the okay fans. So it's not great, but it's also not bad, is kind of my end result with it. And one nice thing I will say about it is it doesn't have any noticeable harmonics in the way I'm currently testing things, which is every 10 PWM fan signal. Now we're taking a look at Stone. Stone is just a different way of looking at noise data. If you want to learn about Stone, I have a whole piece on it on my channel. And same results. Let's keep moving. Now we're looking at performance through my CPU air cooler. Silverstone actually did tell me before testing this fan, they're not expecting this one to do particularly well through an air cooler, and I told them I was going to test it anyways for completeness in my testing, and they said we applaud that and we encourage you to do so. But they're like, we just wanted to let you know not to expect much, and it's like, that's fine. So in terms of blade design versus RPM, that's this left graph here, the Air Penetrator is basically hidden because it's right in line with everything else. So that is a very good result. Once we take a look at noise, it all falls apart for these Air Penetrator fans. They're just noisy for what they do because of all those fins. Now, thanks to viewers like you joining me on Patreon and becoming YouTube members, I was able to purchase a thick boy radiator. Unfortunately, I still don't have a custom loop to put it in, so what this test is measuring the resistance to airflow going through a cooling device. So I have the Noctua U12A and the Nemesis radiator. This is not saying that the performance through them would be the same, meaning if you had the radiator and an air-cooled system and you were running a system, the temperatures would not be the same. It is how hard the fan has to work to push the air through it that is the same, not the cooling potential. Okay, and moving forward, we have noise normalized. We have the red is my 10.5 decibel reading, and the blue is the 17.5 decibel reading, and these are the airspeeds going through the Noctua U12A and how they are ranked at that noise normalized values. Well, the air penetrator is ranked towards the bottom. It's just noisy for the amount of airflow it generates. Locking into 800 RPM, the air penetrator is in the upper middle part of the graph, indicating that it is good at shoving air through a cooler at a particular RPM. The problem is that it's just a bit noisy, as we've discussed previously. Going up to 1,500 RPM, it's starting to fall back to be just kind of the middle of the pack, which again is not a bad place to be. It's just the nature of things where it sits, but it's still putting up a relatively good result. And here's the weighing factor for how it was generated for the ranking. If we move up to 2,000 RPM, the Air Penetrator 120i Pro is basically sitting right smack dab in the middle of the graph. Bumping things up to 100% PWM fan signal, here's the weighing factor for the ranking, and the 120i Pro is sitting towards the bottom. If we're comparing it against other fans that spin around 2,000 RPM, it's doing actually a little bit better than them, but it's just doing it a bit more noisily, we can say. Taking a look at airspeed versus that decibel rating going through the cooler, the 120i Pro is sitting towards the bottom of the graph. It's not at the very bottom, but it is shifted down. Overall, it would do okay. If you had it in your computer case, your CPU cooler fan died, and this is your only option, you can slap it on and it will plug along until you get a different fan. No worries there. Zone again, airspeed versus zone. Zone is just that noise data. And, it's the same thing. Let's move on. Now we're looking at performance from my CPU air cooler. Not the air cooler. Now we're taking a look at performance in my CFM test. CFM is just volumetric flow rate. So the left graph is volumetric flow rate versus RPM, so how efficient is that blade design, pushing air. And it's sitting just above my control fan, indicating, again, a very effective blade design. However, once we take a look at noise versus that volumetric flow rate, it falls apart once again. It's just a little bit on the noisy side. Taking a look at the noise normalized results, the 120i Pro is sitting towards the bottom of the graphs. Again, same story with this fan. 100% PWM fan signal. Bottom middle, again, staying right in line with other 2,000 RPM fans, just a little bit noisier than most of them. And a little bit higher RPM fans tend to do a little bit better than it and deliver a little bit more airflow. Then we got CFM versus decibel rating, and we're reiterating the exact same story. It's just a little bit noisy for the amount of airflow it generates. Now, before I talk about performance per dollar, I do apologize. This was filmed before I got my new test, the CFM 180, as I'm calling it in graphs, up and running. But I do believe that I have a piece on my channel where I go over that new volumetric flow rate test, and it should have this fan's data in it. I believe the date of that video would have been in July sometime, I think July 4th-ish time frame. So if you're interested, do take a look at that. All right, now we're going to talk about value. Value is just performance per dollar. A fan that is cheap enough is going to look really good on these graphs, assuming that it has a certain amount of baseline airflow, just like a really expensive fan with completely awesome airflow. If it's just too expensive for the amount of airflow it generates, it's going to look really bad on this graph. This graph also does not take a look at RGB or blade design. So if those two things are important to you, you're going to have to figure out how much value those add to your fan. This only looks at performance. Another thing to consider is quality of the bearing in the fan itself, something I'm also currently not able to test, but I would like to add in the future. So a brand like Noctua is well known for their fans' long lifespan. So that is another factor that you need to consider and determine for yourself how much of a factor that is when, making the fan purchase, because prices of them can really add up. And I'm just here to present the data. So the Air Penetrator 120i Pro isn't a particularly great value as a case fan at $27. In the CFM test, it's also not a particularly great value, so we're going to keep it moving. And in a CPU air cooler, it's also not a particularly great value. So the TLDR with this fan is, it would work and do just fine as an air cooler or an AIO cooler fan. It would just be a bit on the noisy side, but there would be no qualms on using it in such an application. The main thing you need to consider is the noise level that it's generating, and this fan is not optimized for being on a cooler. It's kind of a waste for it to be on there if you have a different option available. In terms of a case fan, it is one of the best at smoothing out airflow and pushing it through the computer case. That said, it is a bit on the noisy side for the airflow that it generates. It is the nature of the beast. So again, you have to determine how loud you're willing to put up with, and whether you want the most, how good an airflow you actually want it to be. So this should have a more laminar type airflow as opposed to a turbulent one than most other fans on the market. Now, what you're seeing is the raw data for this. The raw data does belong to me and my channel. If you wish to use it for your own personal use, you may go ahead and do so. But if you're going to use it in any sort of video, publication, written journal, or anything like that, you need to reference me and my channel and get my permission first. If you would like access to my raw data, I have two options available. Either sign up for a YouTube membership or Patreon membership. I have two tiers for it that have access to the data. The lower of the two tiers just has access to the data. The higher of the tier has the data and the graphs. You do need to request access because it's not an automated system and it's on a Google Drive, basically. Other than that, I thank you for watching my video. If you like what I'm doing, please think about subscribing and becoming a member. It does directly fund this channel and help support it, because right now it's just me. And I periodically do have companies that are awesome that send me products, but I would like to maintain independence. And but I understand that giving money to a random YouTuber on the internet is not an easy thing to do. So if you just hit subscribe, that really does still go a long way. Tell your friends about this channel and get them watching it too. Anyways, thank you for watching. Have a great day, and I'll see you next time here on Computer Tech and More.